My name is Esteban. I'm the lead of the profilings in Android Studio. And today I'm going to show you all the new features we have in Android Studio 3.2 and some of the features that we launched in Android Studio 3.1 in the profilers. Right. So I'm going to be doing a demo for most of the session. But just in case you haven't seen the profilers before, just to get an idea, how many of you have used the profilers? Oh, okay, that's great. Well, I was going to explain that we have these profilers in the studio, but most of you have seen them. But we have a new profiler that I'm going to be introducing today, that is the energy profiler. As you know, we have the monitors that show you live telemetry from the app. We have the CPU, network, memory, and the new energy profiler. And you can dive into any of those and, for example, inspect your network requests, see where you made the request from code, see what you actually downloaded, what was sent. You can also dive into the memory profiler, see the breakdown of the memory, see how many objects you have allocated, where you allocated them. You can also dive into the CPU profiler. I'm going to be showing some new cool features that we added there in 3.2. Specifically Systrace. Again, I'm going to ask the question, how many of you have used Systrace before? Okay, cool. Now Systrace is, we started with the first steps of integrating Systrace into the Android Studio CPU profiler. I'm going to be demoing that in a few moments. And last but not least is the new energy profiler that will guide you in finding problems in your app that could lead to energy profiling, energy issues. I'll talk more about that at the end of the session. And with that, that's it. That's all the slides that I have. So I'm going to move to the demo now. And I have to make a disclaimer. So all the features that I'm going to be demoing today are in Android Studio 3.2 Canary. And there is a reason why they are not in the stable release yet. So we might be in for a bumpy ride, but I wanted to show you what we have. And if it crashes, we just keep it between us and people watching on YouTube, and that's it. All right. So I wrote last week this clock app. It's a simple clock app that has the clock. It has a stopwatch that you can click and does something. And it has a timer. And I want to profile it with you guys. So let's first start with Network Profiler. So this app has a lot of features that a clock app should not have. For example, it needs internet access. It needs to access location. It has a lot of things, so we can demo this. So please do not write the clock app like this. So one of the features it has is you can change the background. So if the internet connection is good enough, this thing is going to start downloading some images right now. There we go. You can dive into the network profiler. You surely have seen this before. And you can see all the network requests that have been done. You can click on them and see the actual payload. Something new that was added in 3.1 is the ability for us to see what we send. Not just what we receive, but we can see the payload or the custom headers that we use. In this case, I have one custom header that says Google I/O. There is another new feature in 3.1 for the network profiler, and that is the threads view. So as you see here, we show you the requests in a timeline. But if you choose threads view, what you can see is on which thread, and let me close this so we have more space. There we go. So you can see each request on which thread it was made. And if we have more like this, I'm using a standard asynchronous task, which uses a default executor that will run them sequentially, and you can see them. And if they were reusing the same thread, you can see them too. But if in your app you have a more complex threading with network requests, you can use this view to see what's going on. So those are the two new features on the network profiler that we've added in 3.1. And now I'm going to move to the memory profiler. Let me go to the live session. If you have seen this view before, we split up how much memory you are using into different components, but we also show you the number of objects you have allocated. If you are profiling on an Android Oreo phone or newer, we have, and this is super cool, we have a feature called live allocation tracking. Remember back in the day, it was probably last year, when you had to do allocation tracking, you had to click on a button to record allocations, and then you would see them. Well, if we wanted to know what happened here, we can see that the object line is going up, it's being garbage collected. It's going up, and it's being garbage collected. Just if you want to see what's happening, just select a range, and we will have the information of every single object that was allocated there, at which time it was allocated, and where in your code it was allocated. And you can slide this window, and you can see this thing changing. So if I slide it over a garbage collection period, you will see which objects were deallocated. Let me close this window. There we go. We can see that there was a lot of strings deallocated. So we can start actually having a look at this app and see how bad it is written. For example, if I select this and I want to see what was allocated, I can see that there were a lot of strings allocated. I can click on any one of those and see where I allocated them. And I allocated them inside a non-draw. This is not a good idea. If you have a custom view and you allocate a lot of strings there, bad things will happen. And we'll see more about that through the CPU profiler. But this is already starting to tell us signals about what my app is doing wrong. Another new thing that we added in 3.2 is the ability to see JNI global references. This is very important because a lot of memory leaks occur because one JNI global reference is created, and we don't know when we created it, and we don't know where it is. So when you select a range, what I have here in my app, every time I download an image, I run a filter through it in C++ to darken it so the font can be seen. And I have a global reference there, and I hope I did it right? So we have a special heap, which we call the JNI heap, that when you select it, you can see all the global references that existed in this range of time. In this case, I have this int array, and I know I created one, but it should have been gone. So let me go live here and select a range. And here it is. This is my global, this is every image that I downloaded. I'm still holding a JNI global reference to it, and I can actually navigate to the C++ line of code where I created that global reference I never let go. So I hope this is useful to track down problems with global references in JNI. And one more thing. You probably have been seeing all the time on the left that we have a new panel called the Sessions panel. Well, now we allow you to see previous sessions that you have been profiled, so you can navigate back and compare previous runs. So if you're working on optimizing your app and say, what did I change? You can go back and see previous sessions. At the end of the demo, hopefully we can go back and see what we optimized and what happened. But that opened the door for us to do things like this. Now we can import a file. I'm going to import a heap dump. And this heap dump is being imported directly into the new profilers, and it creates what we call a fake session for it. And you can analyze the heap dump as you are used to in the profilers. You can also import traces for CPU, and everything we can export, we can import too. So that's pretty handy this is new in 3.2. Cool. And this is what I wanted to show for memory. And now we're going to go to CPU and spend most of the time there. Right. Where am I? This is the live session. And I'm going to show you one feature that we have. All right. So one thing that we wanted to add was the ability to profile since the beginning. So if you've used the profilers, you notice that if you want to profile your app startup, you have to quickly go to the CPU profiler and click record so you can see what's happening. Well, in 3.2, what you can do is if you go to the profiling tab, we have an option that says start recording a method trace on startup. So I have this ticked. You can choose the configuration that you want. In this case, I'm going to use sample Java configuration. And I'm going to rerun the app. Cool. Now, you can see that the app restarted. The profilers took me directly to the CPU profiler, and there is already a capture in progress from the very beginning of the app. So I'm going to stop it now, and we're going to investigate what happened there. It'll take a few seconds to get the data. Cool. I don't know if you can see the resolution on that screen, but let's have a look and see that I'm going to select the very beginning of the app. In fact, you can see that the capture started even before our telemetry could start getting data from the app, right? Our telemetry started here, but the app started before, and we can see the data. And if we keep zooming in there, you can see the first onCreate of my main activity. And even before that, we can see when all the dexes were loaded and the very, very beginning of your app. So with this mechanism, you can profile from the very beginning and optimize the startup time of your app. Cool. But let's have a look at this capture and see if those strings we saw before are actually causing some problems. One of my favorite views in the CPU profiler is the flame chart. The flame chart aggregates all the call stacks that have the same beginning. So you can see it's basically the top-down tree, but in a visual way. And you can see that one of the biggest things is my own draw. The way I wrote this app is on every frame, I'm rendering everything again. That's not a good way of doing it, but it's a really good example for the profilers. So you can see that I'm rendering, and there is a lot of things at the top that have to do with string formatting. And this could be the source of our string problem that we saw before. So it's another symptom that your app is not doing well. One thing that I always say about our profilers is that we cannot really tell you what's wrong in your app. We can only tell you what your app is doing, and then it's up to you to say, oh, I didn't expect this to happen. Because, as you can see, my app looks fine, but under the hood it's not. So let's say you have a bug on a label that you put wrong, and it's in a different position. You run your app, you see it there, and it's like, oh, it's wrong, I need to fix this. But if you have something like a performance issue wrong, you won't see it. You won't see it until, even, we'll talk about battery later, and you will see it in the field, right? So we want our profilers to be another window to your app so that you can run your app while seeing the profilers, and then you see the problems there because something that you did not expect starts showing up, like me doing a lot of string formatting inside an on-draw call. Cool, so let's go to the code where I have my, can you see? Yeah. Cool, so I have my own draw, and I have a function called drawTime where I draw the time on my app. And I wrote a function called drawTimeString that uses string formatting to draw the time, and that's probably not a good idea. So, oh, that's just, it's a coincidence. I have another function that draws the time without using strings, and we're going to try it. Oh, before we do that, let me show you one thing that we have here. So, how many of you are familiar with this line of code, trace.begin section? Raise your hands. Cool. So, what this line does, and together with the end section, they will create a Systrace event that then you can use Systrace to see. So, before I make my optimization, I'm going to show you what happens if I take a capture using the system trace method. Cool, so this is running Systrace under the hood, and you don't have to go to the Python script anymore and get it, and then get it back on the HTML view. We will instead show it to you right here in our app, under Studio. Okay. Remember what I mentioned about a bumpy ride? This is it. Oopsie, let me restart the emulator, and we'll do it again. There we go. Please try this at home. File bugs, we will fix them. And when we get to stable, these issues will be all sorted out. There we go. I'm going to go to the CPU profiler and use system trace. Second time's a charm. OK. So we have system trace here. Let me select and zoom into the selection. Cool. One thing that you notice here, that first of all, we have a new section there called the kernel section, where we show you all the CPUs. And if you pay close attention, we re-render all the thread information, getting all the data from Systrace. So before, the thread information, we get sampling the proc file system, so it's not very accurate. But as soon as you take a Systrace capture, you can see exactly what your thread is doing at every moment. And more than that, if I select one of those, we highlight above on which CPU your thread is being scheduled. So you can look at thread contention or other things that are kicking you out of the CPU. There is a fundamental difference in the way we show Systrace here with the way you see it in the HTML view. Here, we focus on your app. So everything here that is highlighted green, even the dark green, is just your app. You can still go and see the other events and see what is taking CPU or why you're being kicked out, but we focus on your app. We show you the threads of your app so you don't have to navigate that gigantic HTML page. And we use all the other things that you know about other captures, we use them for Systrace. For example, flame chart or a top-down view. So let me zoom in to a moment in time. There we can see our frames. So I have here, let me zoom in more and choose actually my main thread. There we go. So we can see the choreographer do frame, and further down we can see the on draw on my custom component. And we can see the draw time. Remember in the code, let me go back to the code and show you. In draw time, we have clock draw time around the section, around my time string. And you can see that I'm rendering it 3 times, one for every section of my app. And we can quickly see how long each one of those is taking, right? So I'm taking 38 milliseconds to render a frame. If you want your app to render at 60 frames per second, you have to render under 17-ish milliseconds. Now, I'm way over that. In fact, one of my calls to draw time is taking 11 milliseconds. So my app is not doing well. It looked OK, but imagine you ship this and people complain. This is one of the things that I was mentioning about. You look at your app, but look at it through the profiler glass to see if it's doing OK. Cool. Now, let's optimize and take another Systrace capture. I'm going to change the implementation of draw time. Now, instead of using strings, I'm using my custom formatting. Instead of using a string format, I'm using my custom formatting. We'll run it again with these changes, and we'll run it through Systrace and see how that affected my app. Cool, there it is. I'm going to go to the CPU profiler. Systrace is chosen for me. And I'm starting a capture. Just a few seconds should do, because there are a lot of frames that happen in there. Cool, we have it here. Right. Main thread selected. Let's zoom into a specific frame. We have the choreographer do frame in the framework. And then it goes down to the clock on draw. And you cannot see anymore the draw time functions, because they are tiny, tiny specks down there. Each one of them now taking 71 microseconds. And the on draw is 13 milliseconds now. Woohoo! So we did that. Now, I'm still under 60 frames per second because my app is bad in other places, but at least we optimized one part of it. Cool, and that's Systrace. And let me mention again sessions. So remember I said we can go back and compare? Well, I have my previous sessions here on the left, and we can see the previous Systrace run that we did. So here it is. I can select it again and look at the main thread and see how bad my draw time was, and then go back to the currently running session. And you can keep all of this. And of course, if you right-click, you can export the trace and send it on a bug, or on a heap dump. You can export these things right here from the session panel. So let me click this. Right, and that's our, we have 20 minutes. And that's our integration with Systrace. So there is another way of capturing CPU data that is through an API in the debugger. Let me go to the line of code Here it is. So I have my stopwatch, and I'm going to change it so every time that I start my stopwatch, I'm going to run start method tracing, and every time that I stop it, I'm going to stop method tracing. I need to import the debug class, and I'm going to rerun the app. Now, before this, once you run this API, you had to go and fetch this file and open it in either any of your favorite profilers that can open a trace file. But right now, if I'm the CPU profiler and I use my stopwatch, this is what happens. So now I'm taking a capture, and the studio profilers detected that a capture is being taken place, and we're showing you theirs. And when I stop it, I don't need to go and fetch the file from anywhere. We pull it from the device, and we show it right there. So if I start and stop, and I start and stop, all these captures that are actually overriding each other because they use the same file on device, we're pulling it and showing them on Studio. So that's super handy when you want to profile exactly a moment in time. You can navigate to all of them, and you can see them here in the sessions panel too. So it's pretty cool. One more thing, we added in 3.1, where am I? Another way of capturing CPU usage using the C++ sampling tool called SimplePerf. If you go to documentation in androiddevelopers.com, you will find documentation about SimplePerf. We have a version of SimplePerf inside Android Studio and allows you to sample C++ code and see the entire call stack of your C++ program. I'm not going to demo that because I don't have a lot of C++. Cool, so that's CPU profiling. And let me move to the energy profiler now. So energy is tricky. Energy is tricky because there are two main sources that use energy on your phone. Well, the screen is obviously, I'm not even counting the screen. The screen is bad. It uses a lot of energy, but the user is using the phone. So if you're using a game, right, it's all the time using the screen. But the battery drain problems usually happen when we use CPU or network when the user is not aware of this, or maybe when we as developers are not aware of this. So let me go live. I'm using a fair amount of CPU on this app, and if I go into the energy profiler, we classify this as light use of energy. We will show you here things that, this is a theoretical model, right? So we show you things that represent how much energy you would be using on a modern phone. I'm not profiling how much energy the emulator is using, obviously, but this is for us to see, okay, I'm doing well or I'm not doing well. I'm going to show you some things that show up here. But obviously, the two big factors are CPU and network. And it's not, the obvious thing is, okay, just don't use CPU and network. But how, right? Or why am I using that in the field? And the problem is not actually when we use it. The problem is that we don't know we're using it. So let's say I have a wake clock that runs amok, and we don't know where it is, and that's using CPU. Or I have an alarm that I didn't set up correctly, and that is it's waking my app, and I'm making network requests. So it's not about the actual energy, it's about all these things that you could be doing incorrectly that could cause battery drain in the long term. And this is part of what I was saying before, that if you look at your app, if you look at my app, seems to be running, seems to be fine. If I were to push this app to the Play Store and you install it on your phone, this is going to be the most expensive battery-speaking clock you ever have on your phone. I'm going to drain your battery, right? And I don't know it when I'm seeing this. So by looking at the profilers, we can see that constantly this is draining CPU, and we can start investigating why. Like I said, the common mistakes are I have a wake clock that I don't release, or I have an alarm. So we wanted to give you a window so you can see these things happening. The same way if you have a label in the wrong place, you can see it. We want to show you if you have an alarm that you didn't cancel or you have an alarm in the wrong place, we're going to show you that. So let me show you this piece of my app where I have a timer. So here I can run, let's say, a 10-second timer. And you can see at the bottom of the energy profiler that there is a yellow line that showed up. If I put the tooltip on it, that's an alarm or a job. We show you both there. And you can see that when the timer stopped, the alarm went away. And if I start the timer again, again I have the alarm. And this, actually, when I was developing this, was useful for me to see, okay, am I doing it right? When I stop the timer, does my alarm go away? When I start again, do I call it back? So this allows you to see this. Please don't use alarms for a timer on a clock. I also have a wake clock on my stopwatch. Again, don't use wake clock for stopwatch. And you can see that when I start it, I acquire a wake clock, and when I stop it, I let it go, and I can see that it's working fine. If the red line keeps going, I have a bug, right? My app will look the same, and I will ship it, and people will have problems, but you can see it through this window that whether it's fine or not. And we also track location. So if you are acquiring location like I'm doing now, we have this purple line that shows you that you're acquiring location. The emulator has a really handy feature that you can actually tell it when to send a location event. So in our model, we show you that that is actually using energy. And again, you can see it in the purple bar, and if I stop it, there we go. The purple bar is gone. But more than that, as you are used to in our profilers, we can select a range, and we can show you that you had an alarm, that you had a location request. If I move back, we can select the wake clock, and I'll do it in a second. More than that, I can show you where the location was acquired, which kind of provider. I'm using a GPS provider, so we can see that. We can see the interval times that I chose, where in the code I triggered it. I have a toggle location that happens when I click the button. And if I click on the alarm, not only I can see when I set it the first time, but when I reset it, when I cancel it, so you can see all the places in the code that that was triggered, so I can debug problems when this is not happening correctly. Let me go back and show you the wake clock. It's right there. I select. You can see the wake clock. And you can see every time that I started and I stopped the stopwatch, I was acquiring and releasing the wake clock. And you can see all the call stacks for that when that happened. So this is the power of this. This is not to say, OK, you're using a lot of battery. Well, yeah, I'm a game. I want to use battery, so it's fine. The power of this is so that you can see that your app is doing what you think it's doing. And if it's not, you should go and fix it. So, cool. That's Energy Profiler. Let me show you one more thing that I want to show you. On the left, we have the sessions panel. And let's go back in time. I can stop a current session like this. And then you can click on older sessions. And we can start comparing all the captures that we did back from when I started the talk here. And this was the first time we ran it. And we keep all this information until you restart Studio. So you can compare runs. And let me show you the last thing. And I want to close with that. I'm going to close a few minutes earlier. All right. Like I said before, I'm rendering every frame. I'm doing something that I should not be doing. That is, I'm invalidating the view all the time. And that is using a lot of CPU. So let's go back to my activity where I have the code that does this. So I have my model that I update every frame, and then I invalidate all the time. My model has the ability to know when it has changed. So I'm only going to invalidate the canvas whenever something has changed. And we're going to see the impact that that has on energy, CPU, and so forth. Run the app again. There we go. You can see now that the energy profiler most of the time now is below light. It was above medium before. We can compare with previous sessions. But of course, when I have to render, we can see that the energy usage starts going up. This is because I'm re-rendering my view every time. And you can see the effect here. You can see it on the memory profiler too. If I go back to the memory profiler, remember that line that was going up, 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 and being garbage collected? That is gone. I do have some objects that are being created, and they will be claimed later, like here, but it's not as it was before. Cool. And let me stop the demo and go back to the slides. Thank you.